This is the final video on percentages at National 5 level. This video is on reverse percentages. I want us to think about a problem. I wouldn't be asking you to copy this first problem down. A train ticket costs £100 and a sale 20% of the price is taken off the price of the ticket. The price is then increased by £20. How much is the ticket? Well, you would imagine that we take £100, we decrease it by 20%, and then that amount we increase it by 20%. Your probable initial assumption is that it'll go back to £100. But let's work through and see what happens here. So we're going to reduce, so in the sale, we're going to reduce 100 by 20%. So if we're reducing by 20%, we would have 80% left, so we would multiply by 0.8. We should already know this. So the sale price is £80. Okay. What we're then going to do is the price is then increased by 20%. So we're going to increase that amount by 20%. So the new price, we're going to do £80. If we increase by 20%, that's going to be 120%. So we're going to multiply that by 1.2. So when we increase 80 by 1.2, or multiply that by 1.2, we find that the new price is £96. Okay, it is not £100. So if we decrease something by 20%, then increase it by 20%, we don't necessarily get back to what we started with. These problems are known as reverse percentage problems, and our strategy to deal with this can be done in one of two ways, on which I'll show you. Okay, in a sale, all shoes have been reduced by 10%. Calculate the original price of the shoes with a sale price of £63. The clue in this question as to what you have to do is this word here. When we're looking at percentage problems, if we ever want to work out what has happened before, what was the original price, how much did it weigh before something happened, that is like a problem that we're working backwards. In this problem here, we're told the sale price. Okay, we want to work out what we reduced by 10% to get that £63. And it's not a case that we just add on 10% of 63, because if we add on £6.30 onto this, and then we reduce that whatever that amount is by 10%, we're not going to get this. Okay, there's two methods here. I'll show you both, and you can choose which one suits you. Okay, so for method 1, so if something has been reduced by 10%, that means that 90% is left remaining. So what we can say is that 90% of the price is £63. Okay, our goal is the original price we would take to be 100%. So we're just going to apply some basic proportion to both sides here. We're going to work down to 1%. So we've divided by 90 here. I'll need to do the same to this side. 63 divided by 90 gives 0.7. And then we want to work out the original price, i.e. what was the full price. So we multiply that by 100. We do the same to both sides. Multiply it by 100, and we find that the original price is £70. Because if we think about it, if it was £70 and we reduced that by 10%, well, 10% of 70 is 7, and if we take that away, we're going to get 63. Okay, so this is known as the proportion method. So that's your first method you could use. The second method is that you can set it up like an equation. Okay, so we'll just say, let the original price, we don't know what the original price is, so we'll just let that be X. Okay, so if something's been reduced by 90%, if something's been reduced by 10%, 90% is left remaining. So if we had 90% left remaining, the multiplier would be 0.9. So we've found 90% of our original price, and the answer was 63. Do you see how that's been set up there? 90% of the original price is £63. So if I wanted to work out X, I could divide throughout by 0.9. And we should find that when we work through it, we're going to get the exact same answer, which gives us 70. Both methods give the exact same answer. It's up to you which method you use. Probably suggest that this method might be more straightforward to use for you. This is a word question, we'll just finish it off. The original price of shoes was £70. Okay, we'll do the last example. I'll show you both methods once again. An employee gets a 35% pay rise. The new weekly pay becomes £324. What did the employee earn before the pay rise? The important word here is before. That's the trigger here. That should help you know what you have to do. Okay, so we'll look at the first method, method 1. So we've got a 35% pay rise. So once again, before the pay rise would be 100%. So currently they have 135%. And that is equal to £324. Our goal is we want to work out 100%. To do that, we'll work down to 1. So we've divided by 135. So 324 divided by 135 is 2.4. So 100%, i.e. what he earned, or what he or she earned before they got the pay rise, is going to be £240. If we increase 240 by 35%, we're going to get 324. Important thing here is when you're doing this step, you're doing 324 divided by 135, not the other way about. You're doing this value divided by this value. So that's method 1. Or you could get the exact same answer by using method 2. So we'll just say let X be earnings before wage rise. Okay, so the original earning was increased by 35%, so the multiplier would be 1.35 multiplied by the original amount, and that answer was 324. Okay, I increased the original amount by 35%. We can divide both sides by 1.35. And we should hopefully 324 divided by 1.35, we should get the exact same answer, which we do. You get full marks either way. I would probably argue that this has come up in a paper 1 in the past, which should make this strategy a wee bit more straightforward. I would suggest in following through this strategy where you might have some awkward decimals to work with. What will we say? The employee earned £240 before the wage rise. The most important thing with this is to be able to identify when we do this maths. Okay, we do this maths when it's talking about what happened in the past, what happened originally, what happened before. Okay, so when we see these sort of words here, we're working backwards to find an original amount. Thank you very much.